Welcome back. We're going over multiple choice questions 6 through 10 on the Unit 6 Thermodynamics Practice Test. Question 6 asks, what is the standard enthalpy? Get my pen here. What is the standard enthalpy delta H for the reaction represented above? Here's this reaction. I'm looking for key symbols immediately, and there I see it. Formation. Immediately, I write out my equation. Sum of the products minus the sum of the reactants. And I'm going to plug into this equation. My product here is C6H6. It's actually called a benzene ring. And if you did the Lewis structure for it, you'd have something like that oftentimes. They'll write it like this. Kind of interesting. So, I have one product that has an enthalpy of formation of 83. And I have 3 reactants, all 3 having an enthalpy of formation of 230. After I do the math on this, I end up with a negative 607 kilojoules per mole. A good logic here is to notice that you're going to have 83 minus 690. Immediately, that's not going to be positive, so you're reducing it down to 3. If you're crunched for time, that's a good method to use. Okay, another one of these delta G, delta H, delta S questions. So I'm going to list them out, and I'm going to read this, and I'm just going to start filling it in as I go through it. When solid sodium hydroxide is placed in a solution of barium sulfate, so I'm going to have a double replacement precipitation reaction happening here. The temperature immediately increases. Temperature increases. I know that my reaction is exothermic, making this negative. If this is negative, I can get rid of B, I can get rid of C, I can get rid of D. Let's move on. It then goes on to say that a solid precipitate is formed. Remember in the problem in the past that we did in class, they said a gas was formed and we said it got messier. Well, since a solid is formed, we can hypothesize that it's getting cleaner. They did not show us a reaction, and we can make that assumption. If it's getting cleaner, let me look up on the board behind me. Delta S is negative. Okay, that doesn't narrow anything down here. We see that those two are negative, and that's also negative. Okay, there must be some information here about delta G. We're looking for something that tells us the reaction just happened or didn't just happen. Okay, barium temperature immediately increases. Okay, did it on its own. Spontaneous. A is going to be the answer. All values are negative. Moving on to problem 8. Okay, I put this here as a random question, getting you guys to think about stuff that we did last chapter. Which of the following describes the changes in forces of attraction? Okay. Another way of saying that is stickiness. That occur as H2O changes phase. So we're talking about water particles that were once close together moving apart from one another. Well, what do we know? The thing that makes oxygen, or thing that makes water a sticky particle, giving it a high specific heat, also a very high boiling point, is the polarity of it and the presence of those 2 hydrogen bonds. Notice, when it boils, it's still water. It's water as a liquid here, and it's water as a gas here. It is still water. We did not break any oxygen-hydrogen bonds. We did not form any oxygen-hydrogen bonds. We simply separated it apart, effectively broke the hydrogen bonds that were making it sticky. That allows us to get rid of A. No HO bonds were broken. No HH bonds or OO bonds were formed. B is going to be the answer. Hydrogen bonds were broken. No covalent bonds were broken. These are the covalent bonds. We're not breaking those bonds. They still exist. If we broke them, it would not be water anymore. Ionic bonds between hydrogen ions and hydroxide ions are broken. Not any ionic bonds. We don't have ions in solution here. Covalent bonds between hydrogen ions. Again, covalent bonds do not have ions. That's a function of metals in solution. We do not have any metals. Water being sticky, water having a high boiling point, water doing all the cool things that water does is immediately a function of these hydrogen bonds. Keep your eye out for the word hydrogen bonding in water. They normally go together. Moving on to problem number 9. Problem 9 says, of the following reactions, which involves the largest decrease in entropy? Entropy is delta S. Largest decrease tells us we want the one that is the most less than 0, or the most negative. Let's go through each one of these. In A, we're making a gas, so it's getting messy. We're also going from one thing to two things. That's going to have a very large increase in entropy. In B, we do go from 3 things to 2 things, and everything's a gas, so B can be in the running. In C, we go from 3 things to 3 things, and we do make a solid, but everything is a solid in this case. Let's pretend that's a solid. So we're not changing the number of particles. B is going to win over C. Let's get rid of C. In D, we're starting with 6 things that are all gases, and you're going to 7 things that are all gases. Combustion reaction is actually an exothermic reaction. It's producing energy as well. It's going to get messier. That would have a large increase in entropy. Let's look at E. In E, we make a solid. And in E, we end up with 2 things, and we start with 7. Wow. You're making a solid, and you're decreasing the number of moles by 5. E is going to be the answer. It gets cleaner, which would be equal to the largest decrease in delta S. For problem number 10, let's go through this step by step. If delta G for a reaction is negative, immediately when you see that, you need to write this word on your paper. Spontaneous. Delta G for a reaction is negative at 298 Kelvin. Which of the following must be true? We are going to look for spontaneity first. And that shows up in 2. So we know 2 has to be a choice, allowing us to get rid of choice A. Let's go through the other choices. The reaction is exothermic. Not always going to be exothermic. We know that ice melts at room temperature spontaneously. That's actually an endothermic process. So just because it has a negative delta G does not tell us about delta H. It may or may be exothermic, allowing us to get rid of choice 1, which allows us to get rid of C and allows us to get rid of E. Boiling it down to 2 and 3. This is a tricky distinction. I'm going to try and make it clear. The reaction occurs spontaneously. Would the rate of the reaction also be fast? Rate and spontaneity are not related. Spontaneity has to do with if it just happens. Rate has to do with how fast it is. You can have something melt fast or melt slow spontaneously depending on the temperature. So delta G and rate are not related to each other at all. They are not proportional to each other. They're exclusive. So the rate could be fast or slow. We do not know. So the answer is 2. Talk to you guys later when we move on to the free response. Thanks a lot.